All right, one more Khan Academy section. So this is the big mamma jamba, the one that you're going to really need to be able to do the final part of this chapter with logarithms. Here you're going to be setting up exponential expressions or exponential equations. And to do that, again, it follows a simple pattern of a starting amount. So we have some starting amount. Why won't you write? I guess I have to do it down here. Start times some rate. Ooh, pretend like that's an R. R-A. Sorry, this is taking so long. Rate, and the exponent goes up here. All right, so that's the general format, not hate, rate. Start times rate to an exponent. So a manufacturing plant has earned $80 per man hour of labor when it opened. Each year the plant earns an additional, so we're going to be adding over 100 or over 1 for our rate, an additional 5%. So right off the bat, the starting amount is 80, and then I'm going to multiply that by 100% plus 5% is 105%. After I move my decimal, I'd get 1.05, right? So, and then you have your exponent, which is just t. So watch out that if they give you this little letter in here, after t years, they want you to specifically use that letter. If I would have put an x, Khan would count it wrong. I won't count it wrong on your test, but Khan would count that wrong. Anyways, though, remember how you move your decimal over. So 105% is how you would write as 1.05. You move your decimal over to, and that's how you write 105%. Because timesing by 1 over and over again would just stay at 80. 80 times 1 is 80, times 1 is 80, times 1 is 80. Doesn't do anything, right? That's the 100%. You've got exactly what you've got, no more, no less. But then when you get that extra growth, you add that percentage onto 100, so 105, and then we move our decimal left to get rid of the percent sign. All right, so that's the general way that we set up exponential equations. Try this one here, and I'll let you work on your own. When the Dragons have lost their most recent game, 200 fans buy tickets. For each consecutive win the Dragons have, the number of tickets fans buy increases by a factor of 1.1. So first off, by a factor of 1.1 means that you're getting a 10% increase. So remember, 100% would be staying the same. They would keep having their same 200 fans every time. But if they're getting another 10% increase, my percent sign's on here, 100% is the same amount of fans plus a 10% increase for every consecutive win. Every time they win in a row, they get an extra 10% of fans is obviously 110. Woo! Whatever. 110%. But we don't want to have to work with that percent sign in the problem. So what we do is percent means per 100. So you divide by 100, moves your decimal left to. That's where that factor of 1.1 comes from, is a factor of 1 would be multiplying by 1. Doesn't do anything. It's just having the same amount each time. They would stay their 200 fans. The extra decimal is the additional amount each time. That's where the thing grows by. So when you set it up, you would have the 200 original fans times 1.1 to the, what is the variable? W, to the W power. That's the general form every time. So spend some time practicing that. You're going to have to be really good at that. This is the core idea for this chapter. If you can do this, you'll pass your test, even if you can't do anything else with it. So make sure you spend some time working on that before you move on to the the logarithm section of this chapter.